Hello. Now we have Fundamental Theorem of Calculus, Day 2. So first, some background stuff we've talked about before. So dy dx, that's a derivative. Hopefully you know that. The integral of dx, and that's an integral, right? We also know that the derivative of the integral of f of x dx is just f of x. So let's look at this. So the derivative of the integral of 2x dx, so we're differentiating the integral itself, is the same as differentiating. So if you integrate 2x, if you antiderive it, you get x squared. So this is the same as the derivative of x squared plus c, which is 2x. All right, you may not see the purpose of that yet. You probably don't, but hopefully it made some degree of sense. So now, what does the derivative from 4 to x of f of t dt mean? Well, derivative is a rate of change, right? So it's the rate of change of the area under the curve that's the integral of f of t from 4 to x. Doesn't really mean a lot to anybody, right? Well, it is what it is. So it's a stupid saying, but it is what it is. So let's do some examples. So if we look at the integral from 0 to x of cosine t dt. The integral of cosine is sine. We don't need a plus c because we have limits. So it's a definite integral. Kinda. There's an x in there, but it's still a definite integral. We're evaluating from 0 to x. So we get sine of x minus sine of 0. That's just 0, right? So we get sine of x. The derivative, sine of x, is cosine of x. Here's where we make the jump. So the derivative of the integral from 0 to x of cosine of t dt is cosine of x. Let's sit with this for just a second. I suppose you could pause it and sit with it as long as you want. But I'm going to sit with this for just a second with you. So we found the integral. So integral from 0 to x of cosine of t was sine of x. And so then if we differentiate that integral, it's the same as differentiating sine, which is why we end up with cosine. Let's look at another one. The integral from 5 to x of 2t plus 3 dt. Integral of 2t is 2t squared over 2, which is t squared. Integral of 3 is 3t. Evaluating from 5 to x. So we get x squared plus 3x minus 5 squared plus 3 times 5, which is x squared plus 3x minus 40. The derivative of x squared plus 3x minus 40 is 2x plus 3. So it must be true that the derivative of that original integral from 5 to x of 2t plus 3 dt is 2x plus 3. So again, we took this integral and we got x squared plus 3x minus 40. We took the derivative of x squared plus 3x minus 40 and got 2x plus 3. So if we differentiate that original integral, we should also get 2x plus 3. So now we have a rule. Rules are nice. The derivative of the integral from a to x, so any constant to x, of f of t dt, you just get f of x. Just plug the x right in. Another way this is sometimes written is, it means the same thing, but if f of x, uppercase f of x, from a to x of f of t dt, rather if f of x equals that integral, then f prime of x, uppercase f, equals f of x. So that's another way it's written. I don't always think about it too much. So then if we want to take the derivative from x to 2 of cosine of t dt, if you recall the rules for definite integrals, or the properties rather, when we flipped the limits, the sign changed, the sign became opposite. So instead of being cosine of x, this is going to be negative cosine of x. Because if the variable is in lower limit, sign is opposite. Because you'd basically end up with, in this case, sine of 2 minus sine of x when you integrated. And then you integrate, and basically everything would cancel, but you would end up subtracting, so that's where the negative comes in. Sorry if that made no sense. So you can prove it to yourself, or you can just believe me. It's totally up to you. And then the other piece, if you take the derivative from a to g of x, so now it's a function of f of t dt, you get f of g of x times g prime of x. It's basically chain rule. This rule looks a lot worse than what it actually is. And again, there's the other one where we say if uppercase f of x equals the integral from a to g of x of f of t dt, then f prime of x equals f of g of x times g prime of x. Again, the ones in the parentheses don't worry about too much. So basically, if you have a variable in the top limit, you just plug it in for the t. If it's in the bottom limit, you just make it negative. If you have a function, you have to account for chain rule. So we have more examples. It seems like I should switch to the pretty blue color now. So if we have the derivative of the integral from pi over 2 to x squared of secant t dt. So I'm differentiating, and there's a t and there's an x in one of the limits, so I know I'm just going to plug that in. It's on the top, so we just make this into secant of x squared. But since that's a function, it's really just chain rule. Derivative of x squared is 2x, so we multiply by 2x. And that's our answer. If we differentiate the integral from x cubed to 3 of tangent of t dt, well, we plug in our x cubed for our t, so that's the function I see. And then this variable's in the lower limit, or the function's in the lower limit, so I have to make it negative. And I have to multiply that by the derivative of the inside function, so 3x squared. So I get negative 3x squared times the tangent of x cubed. I'd like you to pause the video and try a few more. Try the derivative of the integral from 0 to x of e to the negative t squared dt. And try the derivative of the integral from x to 5 of 3 sine of t dt. And lastly, try the derivative of the integral from 1 to x squared of cosine t dt. Again, please pause and try these, see where you get. Okay, I'm assuming you paused. I feel like I have to pause for a minute too, even though I don't really. So for this first one, this is going to be e to the negative x squared. Okay, put in the x for the t. This is just an x, there's no function, we don't need to worry about that. And the x is in the top limit. Second one, 3 sine of x, put in the x for the t. Since this variable is in the bottom, we have to make it negative. Switch the sign. For this last one, we'll put the x squared in for the t. The limit's in the top, so we don't have to make it negative, but it's a function, so we have to multiply by its derivative. So we have times 2x. I would typically write this as 2x cosine of x squared. There's a bunch of homework problems. Make sure you try them. Maybe even if you don't normally do the homework. Just kidding, I know everyone does. No, no one does. Try them because this is a fairly straightforward rule, but if you don't practice, odds are you'll make mistakes. So please do your homework, practice. Let me know if you need anything else. Have a great day.